Okay, so yesterday where we stopped was, so we did talk about the continuity, okay, which is not that important actually for the course, but it's still part of some of your homework, so that's why I covered it. And now, so let's try to revisit the libraries of basic functions, okay? So most of these graphs will be something that we have seen already. So the first one, f of x equals x, okay? So now remember, that's same thing as y equals x, right? Okay, and if you remember from yesterday's class, that is the line, right? And it passes the origin, and since the slope is positive, which is 1, it is an increasing line, right? Remember that? Okay, and now the second one, f of x equals x squared or y equals x squared. Okay, so now remember that's not a line, first of all, and that's a parabola, right? And it's the U-shaped curve, right? So something like this. Okay, so we'll study in detail about this quadratic function or x squared in the next section, 3.1. Okay, and then the third one, f of x equals x cubed or y equals x cubed. Okay, so now this one, so this is another curve, right? But its graph is what? The S-shaped curve, remember that? Okay, so the graph looks like this. Oops, something like that, okay. And now, f of x equals square root of x. So what does that mean? We have y equals square root of x, and if you remember, that is kind of half curve, right? Okay, so the anchor point is at the origin, and then it kind of increases slowly. Remember that? And then another root, which is the cube root. Okay, so for the cube root, and that's basically the extension of this square root curve onto the third quadrant. Remember that? So it's kind of the S-shaped once again, but it's slightly different compared to the cubic function. It looks like this, right? Okay. And then the last one, y equals 1 over x. Okay, so y equals 1 over x. So y equals 1 over x. So that is, so that is this one, right? Okay, the two curves which are on the first and the third quadrant. Okay, so anyways, there's a reason that we revisit these libraries of graphs, because these will reappear a few times, not just in this section, but also in the future sections. Anyways, so the core of the section is not this library of functions, but it's this one, the piecewise function. Okay, so now, sometimes some other textbooks call it piecewise defined function. So maybe some of you have seen this or heard about this before. So for those who have not heard or who forgot, a piecewise function is a function consisted of multiple formulas. Well, actually, you cannot see it. So let me just write on the next line. Multiple formulas for different pieces of x. Okay, so here comes the name piecewise function. Okay, so for different pieces of x, there will be multiple formulas. Okay, so alternately we can say the intervals of x instead of the pieces of x. Okay, and now this is the definition, and there are two tricky things: finding the function value and the graphing. And which one is more trickier? The graphing is trickier. Okay, so can I go to the next page? Okay, so the next page has an example of a piecewise function. So that is an example of a piecewise function. Okay, so now what do you notice here? So far we have seen, like for example, f of x equals like 2x plus 4, and then there's no if part either, okay? So something like that. Okay, now that is a linear function, right? Because that has the slope 2 and the y-intercept at 4. Okay, and then similarly for minus x, it has the slope -1 and the y-intercept is at 4. Okay, now here there are two weird things. There's a open bracket, okay, and then there is the if part. Okay, so what does this function even mean? So there are two ways to define actually, okay, and the first way to define is, so we have y equals 2x plus 4. Okay, now remember f of x is the same thing as y, right? Okay, now that is true when x is less than 1, so when your input is less than 1, and your function formula changes into 4 minus x if your x goes beyond 1. Okay, now that's what it means. However, sometimes people are still confused with this definition. So if that's the case, they usually get this illustration, okay, of this piecewise function. Okay, so now here's the illustration. So here's the number line of x values. Okay, and on this number line, there is a boundary or threshold value which is at 1. Okay, and now I will shade this region, okay, on the left side of 1, and then I will put this closed parentheses. Okay, and now what does this region indicate? That means x is less than 1, right? Okay, and now for all the values in that shaded region, all of these are governed by the 2x plus 4. Okay, so now what does that mean? For all the values in this region, they need to be plugged in to 2x plus 4 to get the output. Okay, now I will shade this region, and then I will put an open square bracket. Okay, and now what does that represent? That means everything greater than or equal to 1, right? Okay, and now for all the values in this right region, they are controlled by 4 minus x. Okay, so what does that mean? For all the values in the right-hand region, including 1, they need to be plugged into 4 minus x to get the output. Okay, so basically there are, how can I express? There are two kings in one land, okay, and they do not disturb each other. They do not fight against one another, okay, and they just control their own land. Okay, and there's no conflict like we had in like what, Civil War in like 1864 or so. Okay, like there's no war. Okay, so there's no conflict and they're kind of in peaceful mode. Okay, anyways, so that is what this piecewise function means. Now remember I said that graphing is trickier, so here is my suggestion of graphing a piecewise function. So to graph a piecewise function, there are two schemes that you have to use. Number one, you have to choose about 3 x values per piece. Okay, now what does per piece mean? There will be the if parts, okay? So for each piece of x, pick about 3 x values. Okay? And here, when you choose these x values, make sure to include the boundary value, including the boundary value. Okay? and then plug them in. Now, I guess I have to zoom out a little bit so that you can see things better. So maybe that's better. Okay, so for these 3 x values per piece, you have to plug them in to the corresponding formula. Now here, I said formula, but this formula is different from something like quadratic formula. Okay, here, what does formula mean? Like, for example, if we go back to this above example here, the formula, there are 2 formulas here, 2x plus 4 and 4 minus x. Okay, so for the corresponding x values, you have to, of course, choose the right formula, and then you have to plug them into the right formula as well. Okay, so that's the step number 1. And then for step number 2, if you have less than or greater than inequalities, you have to put an open circle, okay, which means this, at that point. And for the other 2 inequalities, which involve the equal to part, you have to put a closed circle, okay, which is this, at that point. Okay, so that's the scheme to graph a piecewise function by hand. And the thing is, even if you use a calculator, you cannot really use it, because your calculator cannot accept this piecewise function unless you're using computer algebra system, which is illegal. Calculator is illegal, so how can computer algebra system be legal? Okay, so anyways, so let's look at the next few problems. Okay, so this piecewise function is tricky, and surprisingly, even the regular college algebra students, like the real college people, like some of them tend to struggle. So if you feel like this is tough, you're not the only one. Anyways, so here is the same piecewise function actually. So given this piecewise function, find the followings: f of -1. Okay. Now here, so far what we did was, okay, so there is a number inside parentheses, so we have to plug in that number to x. Right? That's what we have done so far. Now here, can we plug in -1 to here, oops, and here? And here and here as well. Can we do that? No, because now for the piecewise function, what you have to answer is, what you have to ask yourself is, where is that -1? Okay, so that must be the first step. Okay, in other words, in which piece of x is x equals -1 belonged? Okay, so that must be the first question that you have to ask yourself before you do something. Okay, so now let's go back to the above picture here. Okay, because that picture helps people a lot usually. So now, where is -1? So remember, -1 has to be either on the left or on the right, right? There's no other option. Okay, and now where's -1? Somewhere here, right? Okay, so what does that mean? Negative 1 will be controlled by 2x plus 4, not 4 minus x, right? So what does that mean? So again, going back to here, negative 1 is on the left, which means it's under x being less than 1, right? Okay, so what does that mean? Plug in x equals negative 1 to where? 2x plus 4 only, right? Okay, not 4 minus x, because that controls the other region, right, which negative 1 is not belong to. Okay, so what's the answer? 2 times negative 1 plus 4. So what is that? Negative 2 plus 4, so that's 2, right? Okay, so don't say, oh, the answer is 2 and then 5 for the second piece. No, okay. 5 is not even part of this answer. And you know that the output cannot have two values for the same input. Okay, otherwise that's not a function, right? Okay, so that's how you find the function values about the piecewise function. And now, f of 1. Okay, so same thing. Where is x equals 1? So in other words, is it in the top piece or in the bottom piece?
Bottom.
The bottom piece, right? Yeah, do you see that? Okay, so 1 is greater than or equal to 1. Okay, so we choose the second piece. Okay, so what does that mean? We plug in x equals 1 to 4 minus x only. Okay, this time we don't touch the top piece because 1 is not less than 1. Okay, so what does that mean? 4 minus 1, which is equal to 3. Okay, and then f of 3. So here, since 3 is greater than or equal to 1, 3 is not less than 1, right? Okay, so we choose, once again, the second piece. Okay, so once again, we choose the second piece. So what do you get? 4 minus 3, which is equal to 1. Okay. So remember, for the piecewise function, you should not plug in the corresponding value into two representations, two formulas. Okay, that's not how piecewise function works. Okay, so first you have to choose where your input value is, and then you have to plug in that number to that corresponding formula only. Okay, now any questions over these finding function values? Now, the real thing is the graphing. Okay, so now, since we cannot see the piecewise function, let me copy what we had. So I think it was 2x plus 4 if x is less than 1, and 4 minus x if it's greater than or equal to 1, right? Okay, it was this one. Now, so remember, how do we graph? So for each piece of x, we have to choose about 3 x values, and then we will plug them into the corresponding formula to get the corresponding output, and then we have to make sure what kind of dots we put at the boundary points. Now, let's start with the first piece. Okay, so x is less than 1. Okay, so now, what do you want to choose for the x values? So what are some x values that we can choose?
0.
Okay, and then
1,
Okay, and then
2.
well, 2 is not less than 1.
Oh, yeah. -1.
So -1, yes. Okay, so now some of you might ask, well, 1 is not less than 1, so why do we ever choose 1? Well, because 1 is the boundary point, right? and also, what kind of dot, excuse me, what kind of dot do we put at 1?
Open.
Open, right? Yes. Okay. So at 1, we put an open circle. Okay, so now when x is equal to -1, what is the y value? It's -2 plus 4, so that's 2, right? And when x is equal to 0, the y value is what? 4, right? And now be careful. If x were 1, okay, I didn't say when x is equal to 1, I said if x were equal to 1, what would be the y value? 6, right? Okay, that would be the case, but of course, that's not part of the first piece, right? But that's okay, because what does open dot represent? That's not actually the point, right? That's a missing point, but still we have to put an open dot there. And now, the second piece, x is greater than or equal to 1. Okay, so now here, what can we choose as the x values?
One,
And
2,
and
3.
3, yeah. Okay, now this time, what does this one represent? What kind of dot do we put there? A closed dot, right? Why? Because now that is the legitimate portion of this second piece, right? Because 1 is greater than or equal to 1. Now, when x is equal to 1, what is y? 3, right? And when x is 2, y is 2, and when x is 3, y is equal to 1, right? Okay, so this time we got how many points? 6 points, right? Do you see that? Each row corresponds to a point, right? Okay, so let's plot them. Okay, so graph. And let's see, I guess it's better to go down a little bit. So here's the xy plane. And -1, 2. Okay, so -1, 2. So somewhere here, 0, 4, that's here. And then 1, 6 will be somewhere here, but remember that's an open dot. Okay, and then 1, 3. So 1, 3 is here, and that is a closed circle. And 2, 2. Okay, so that's here, and 3, 1, that's here. Okay, so we have plot the 6 points. Now, can you see how the graph should look like? So here the scheme is don't ever try to connect all 6 points. Okay, so let's look at some portions of the 6 points, namely these 3. Okay, 1, 6, 0, 4, and -1, 2. Okay, so they're here, here, and here, right? Now, do you think they form some kind of graph? Yeah, it's a line, right? Okay, that looks like this. Okay, now here comes the trick, another tricky part. Do we extend our line beyond this empty dot like this? No. Okay, and what's the reason? Because if we do, what's the problem? So here is the boundary point, which is 1. And this portion corresponds to what? Anything greater than 1, right? Okay, but remember, the first piece, 2x plus 4, is valid only when x is less than 1. Okay, so we should not extend our graph after this point. Okay, so that's false. Now, do we extend our graph after that point? Like this? And the answer is yes. And what's the reason? Because this portion here on the left side of 1 is anything less than 1, right? And remember, 2x plus 4 is valid only when anything is less than 1. So, of course, we have to extend our line like this. Okay, so it's kind of the portion of the line. Okay, it's like the chopped off line. Okay, so that is the first graph. And now the other 3 points. So obviously they form another line. And now same question as before, do we extend our line after this point? Like that? No. And what's the reason? Because if we do like that, then this portion corresponds to anything less than 1, but that's false, right? Because for the 4 minus x, it's valid only when x is greater than or equal to 1, okay? So we don't ever extend our line, okay? And now what about beyond this point, 3, 1? We do, right? Okay, because this entire portion is for anything greater than or equal to 1. Okay, so now let's clean things up. So how does the graph look like? It's obviously looks messy, but the graph looks like something like this. Okay, so that is the graph. Okay, so what do you notice here? This is obviously not continuous, right? Because of the jump, right? Like the graph jumps from one to the other. But still, that's a function, okay? Because it passes the vertical line test, even at this break. Okay, even at this break. So, yeah, it is weird, and that's normal for a piecewise function. Now, does every piecewise function have to show this jump as part of the graph? Well, you'll see. Okay, well, you'll see. So, let's look at a few more graphing problems. Okay, so now, f of x equals negative 3x minus 3 if x is less than negative 2, and 3 if x is in between negative 2 and 1. Okay, so once again, here, there are 2 pieces of x. Okay, so what do? We'll do the same thing, right? Choose about 3 points per piece and then plug them into the right formula. Okay, so the first one, x is less than negative 2. Okay, so now here, what can we choose for the x values?
0, 1, and 2. Oh, no, that's negative 2.
Yeah.
Negative 4, negative 3, and negative 2.
And negative 2 as well, yes, right? So negative 4, negative 3, and negative 2. Okay, now at negative 2, we have to have an open dot, right? Okay, because we just have less than negative 2. Okay, so now when x is negative 4, what's the value of y? It's positive 12 minus 3, so that's what, 9, right? And when x is negative 3, the y is 9 minus 3, so that's 6, right? And now, if x were negative 2, what would be the y value? 6 minus 3, so 3 would be the y value, right? Okay, but negative 2 comma 3 is not part of the first piece, right? And now, the second piece, negative 2 less than or equal to x less than 1. Okay, so now here, what can we choose as the x value or x values?
-2, 0, and 1.
Negative 2, 0, and 1, okay? Or if you want, you can choose negative 2, negative 1, and 1. But you have to include what? Negative 2 and 1, right? Okay, so at negative 2, we have to have a closed circle because of less than or equal to, right? Okay, and at 1, we have to have an open dot because we have less than 1, right? And now, for these three x values, what will be the y values? There's no x that we can plug in because we just have 3, right? Are we in trouble? No. What would be the y values here?
3.
All 3's, right? Yeah, okay. Okay, so now let's graph. So graph, okay, so here's the xy plane. Now negative 4, 9. Okay, so the numbers are getting bigger. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9. Whatever. Okay, so somewhere here. Okay, and negative 3, 6. 8, 7, 6. So that's somewhere here. Negative 2, 3. So 5, 4, 3. And that's negative 2. And that's an open dot. And now go to the second piece, negative 2 comma 3. And that's the closed dot, which is right here. And negative, oh no, 0, 3. So that's here. And then 1, 3. So that's an open dot. That's not 30, right? That's not 30, okay? It's just 3 and then open dot. That's not a 30, right? Okay, so now, can you see how the graph should look like? So for the first 3 points, we can connect them and we can see that the graph is aligned, right? And now, do we extend our graph after this top point, negative 4, 9? We do. And what's the reason? Because the first piece is valid when x is less than negative 2, right? So there has to be a graph after this negative 4, 9 as well, right? Now, what about after this point? Do we extend it like this? No, okay. And now, these 3 points, so they form a horizontal line, right? Okay. Now, do we extend our graph after this point and that point? No. And why not? Because this is valid only when x lies in between negative 2 and 1, which is this one, right? Okay. So that's the graph. And now, another point. Let's look at this point here. So if we magnify it, we have this, right? Kind of looks like an eye. Anyways, but that's not a point. Okay, so if we have an open dot and closed dot at the same time, which point wins the battle? Open dot or closed dot?
Closed.
The closed wins, yes. Okay, so this is same thing as the closed dot. Okay, So in short, how does the graph look like? The graph looks like this. Okay, so that point is a legitimate point. That's not an open dot. Okay, okay, so that is the graph. So this time, what do you notice? We don't see any jump, right? Okay, but rather we just see an open dot, and that's it. But we could see this like sharp transition point. Okay. Yeah, I know it's weird, but that's okay. Piecewise function is meant to be weird. Okay, so can I go to the next page? Okay, so now, two more problems about graphing. Okay, so now, f of x equals x squared minus 9 over x minus 3 if x is, and we have seen that symbol before, not equal to 3, right? And 5 if x is equal to 3. Now, before we do graphing, can we do something for this top piece?
Simplify it.
How?
Split the fraction in half and simplify the back half.
Okay, how? So in particular, what can you do for this numerator? Does it remind you anything whenever you see like x squared minus 9? So I guess my hint is compare that with x minus 3. So yes, we will simplify, but there is something that we can do at the top in order to simplify. So here comes another hangman, okay? So F, does it remind you anything?
Foil.
Here's the next syllable.
Factor.
Thank you, okay, factor. So when you factor, what do you get?
X minus 3.
And? X minus 3 and? What is the second factor?
X plus 3.
X plus 3, right? Difference of squares. Okay, so now, why is this important? Because we have x minus 3 over, or times x plus 3, all over x minus 3, right? And now, do you see a way to simplify? Yes, which is what? X minus 3 cancels, right? Okay, so what do you have? Just x plus 3, right? Okay, so what do you notice here? This entire fraction is same thing as x plus 3. Okay, and now we will choose some x values. So for the first piece, x is not equal to 3. What can we choose as the x value?
One, 2, and 3.
Okay, 1, 2, 3. And then let's choose 4 as well, in case like something bigger than 3. Okay, now here we don't have an inequality, right? But instead we have equal to and not equal to. So what does that mean? For the first one, as long as something is not equal to 3, we are good to go, right? But of course, we also choose 3 as well. Why? Because at 3, what kind of dot do we put?
Open.
Open, yes. Okay, because officially 3 is not part of the first piece, but we still have to put this boundary point, okay? So now, when x is equal to 1, what's the value of y? So here you can plug in 1 into this fraction, but you don't have to. Why? Because we deduced that that's same thing as what? X plus 3, right? Yeah. So what does that mean? When x is 1, y would be 4. And when x is 2, y is 5, right? And if x was 3, y would be 6 and 7, right? Okay. And now, the second piece, x is equal to 3. What can we choose as the x value?
Only 3.
Only 3, right? Yeah. Do you see why? Because it just says x is equal to 3, and everything else is false, right? Okay. And although this is kind of stupid and obvious, at 3, what kind of dot do we put? Closed, right? Okay. And when x is equal to 3, what's the value of y? 5, right? Because that's what this one says, the second piece. Okay, so this time we cannot choose 3 x values for the second piece, okay, because there's only one legitimate value. Okay, and now graph. So how does the graph look like? So here is the xy plane, and 1, 4. 1, 4. 1, 2, 3, 4. So that's here. 2, 5. That's here. And then 3, 6. That's here, but that's an open dot. And then 4, 7. Somewhere here. And then 3, 5 is right here, the closed circle. Okay, so now can you see the graph or how the graph should look like? So first of all, these points can be joined, right? Okay, so they form a line. Now, do we extend our line after 1, 4 like this? Do we extend our line? Yes, we do, right? And what's the reason? Because as long as your x is not equal to 3, we have to have this line. So it goes like this, right? And now, how do we take care of this one point here, that point? So that has to be the part of this line, right? But again, same question. Do we extend our line after 4, 7?
You extend it.
We do extend it. Okay, and what's the reason? Because as long as x is not equal to 3, we have to have this line. Okay, so we have to have this almost a line, except what? This one point, right? Okay, and now, do we join these 2 points like that? Okay, and how does the graph look like? This one. Okay, in other words, it's this one, and then this. Okay, so it's almost a line, except that at missing 1 point, you have a teardrop. Okay, so that's the graph. Oh, weird, right? Okay, yeah, piecewise function is meant to be weird, and its graph will kind of look bizarre, so it's normal. Okay, so now the ultimate problem, hopefully you can see why it's the ultimate problem. Oh, because you have 3 pieces. Oh, how bad is that? Okay, but that's okay. It's the ultimate problem, so Yeah, it's just tough. Now, even though we have 3 pieces, what do? We'll do the same thing, it's just more work. Okay, so first one, -4 less than or equal to x less than -2. Okay, so here, what do we choose? I guess we can choose -4, -3, and -2, right? Those are the 3 obvious values. Okay, and now at x equals -4, we will put a closed circle, and at x equals -2, we will put an open dot, right? Okay, and now when x is -4, y is -12, and then -9, for x is -3, and when x is -2, we get -6, right? Okay, and now the second piece, -2 less than or equal to x less than 0. Okay, so now here, what can we choose? Maybe -2, -1, and 0? Kind of 3 obvious values, right? And now here, what are the y values? It's fairly simple, right? It's all -6, right? Okay, and at x equals -2, we put a closed circle, and at 0, we put an open dot. Okay, and then the last piece, 0 less than or equal to x less than or equal to 3. So let's see here, we have to choose 0, and we have to choose 3, and maybe 1. Or you can choose 2, right? It doesn't really matter. So now, when x is 0, what's the value of y? So that is gone, so you just have -6, right? And when x is 1, what do you have? 2 times 1 squared, so that's 2 minus 6, so that's -4, right? And when x is 3, what's the value of y? So it's 2 times 3 squared minus 6. And then we do this one first, right? So it's 2 times 9, which is 18 minus 6, so that's 12, right? Okay, and then at 0 and 3, we put the solid dots, right? Okay, so now we got these 9 points, which is a lot, and we just have to plot them. Okay, so let's plot these points. Okay, so here is the xy plane, -4, -12. Okay, so now since the number is kind of getting bigger, let me go by the units of 2. So that's -2, -4, -6, -10, or -8, -10, and -12. Okay, so first -4, comma -12, so that's here, and we have to put a closed circle. And then -3, -9, so that would be somewhere here. -2, -6 is here, and with an open dot. And then -2, -6 is a closed circle. -1, -6 is somewhere here. 0, -6 is right there. And then 0, -6 becomes a closed circle. And then 1, -4 will be somewhere here. And then 3, 12. Okay, so now 3, 12, 2, 4, 6, 8, 10, maybe here is the 12. So 3, 12 is somewhere here with a closed dot. Okay, so now we plot every point. And now, can you see the shape of the graph? So first, the first 3 points, they are a line, right? And now, remember, we do not extend our graph beyond this point, or even this, right? Because this first line was only valid when x lies in between -4 and -2. And then the next 3 points, they form a horizontal line, right? And because of the similar reason, we do not extend our horizontal line, right? It's just that piece, right? Okay. And now the next 3 points, do they form a line? Is this a line? So it was 2x squared minus 6. So no, it's not a line, right? Okay. And based on how these 3 points are lined up, does it look kind of curvy? Is that even a word? I don't know. Curvy? Okay. So it looks like this, right? Still looks kind of a line, but it's not a line, right? Okay. And now, do we extend our curve after this 3, 12? No, right? Okay. Okay, we don't, because x has to lie in between 0 and 3. So what does that mean? And remember, here at these 2 points, we have both open and closed, right? And from earlier problem, what did we deduce? When both points are matched, the closed point wins, right? Okay, so how does the graph look like? It's this one, but if you want a nicer version, it looks like this. Kind of a what, chair? Okay, so that's the graph. Okay, so now here we have seen a few versions of the graph, but which graph is the most important? If I have to choose one, I would say that graph is the most important. Okay, because that's the standard version of the piecewise function graph. For the other 3 problems that we have seen, yes, they are legitimate piecewise function graphs, but the very first one that we did is the most standard one. Okay. Any questions on graphing piecewise functions? Okay, so now the last concept of the section is about the absolute value function. Okay, so all of you have seen absolute value before, I know that. So you can easily fill in the next 3 blanks. Absolute value of 2 is 2. Absolute value of -5 is 5, right? And now, by the way, what is absolute value of 0?
Zero.
Okay, so now what can you conclude from these 3 problems? Absolute value of a, which is a number, is equal to itself if what? So when is the number come out without being touched? When that number is what? Positive, right? Okay, now can that number be 0? Yeah, because when it's equal to 0, we still get the same number back, right? Okay. Now, what happens when a is negative, when the inside number is negative? So, for example, absolute value of -5 is equal to 5. So the question is, how do you get 5 from -5? Don't say add 10. There's no addition here. How do you get 5 from -5?
multiplied by -1.
which is equal to negative a, yes. Okay, so now, that's the definition of the absolute value. Now, when people see this negative a, sometimes they ask, well, absolute value cannot be negative. So how can you have negative number here? Well, is negative a the negative number? And the answer is no. Why? Because a was negative from the beginning. So what's the sign of negative a? Positive, right? Okay, so this entire thing is positive. So, oh yeah, I'm not violating the math. Okay, so how can you define the absolute value function from this? Very simple, replace a by x. So absolute value function is this one, which is equal to x if x is greater than or equal to 0, negative x if x is less than 0. Okay, so there are the if parts and the open curly bracket. And where have we seen this before? Piecewise function, right? Okay, so this absolute value function is a piecewise function. And we have seen how its graph looks like. Remember that? How does the graph look like of the absolute value?
It's a V shape.
The V, yes, right? Okay, and we have seen another problem where this sharp point is a legitimate point, right? Okay, so actually there is like open and closed dot here at the origin, but since when both points meet, the closed dot wins, we have to have just this regular V-shaped graph. Okay, so just trying to give you an example that absolute value function is a piecewise function. Okay, so that's it for 2.6. Any questions from this? Okay, so now the next one is 3.1. Okay, so the 3.1 quadratic functions. Okay, now in chapter 1, we saw quadratic equations which look like ax squared plus bx plus c equals 0. Quadratic function can be defined from this. Now, a quadratic function can have one of these two forms. Number one, instead of putting equals 0 from here, just put f of x in front. Okay, and now alternately, you can also have something like this. Okay, now here, h and k, we have seen h and k before, which was from the center of the circle, but there's no circle here. And yes, I know it's kind of bad representation, but that's how the textbook does, which is bad. So it's a times x minus h squared plus k, okay? So sometimes people say that is the standard form, and that is called the vertex form. But the name is not that important. The name is not that important. And you'll see why it's called the vertex form for the second form. There's a reason. Now, let's define some terminologies. Or the graph of any piece or quadratic functions. The graphs of any quadratic function is called the parabola. Okay, so we have mentioned this a few times, right, in the past. How does the parabola look like?
U shape.
Okay, now the U-shaped or what? That's not it. there's another kind. So this or one more. What is the another kind of parabola that's also possible? Is the upside down U possible? Yeah, right? Okay, so it's one of these two. Okay, now let's look at the first graph here, the regular U-shaped. Is it opened upward or downward? Upward, right? Okay, so this one is opened upward. Now, this is same thing as concave up. When you take calculus, you'll see another definition of the concave up, but here in this 3.1, concave up means opened up. And what does this represent? Open downward, right? And similarly, this means concave down. Okay. And now, opened upward parabola, the regular U-shaped, is possible when A is what? Positive. And hopefully you remember this. And now, where is A? What does A represent? A is the number in front of x squared or the number in front of the parentheses, right? Okay, so if that number is positive, we have the regular U-shaped curve. And open downward means your A is negative. Okay, so that is the way to tell what kind of parabola we will have. Okay, and now the second definition, vertex of a parabola. So vertex means either the maximum or minimum point of the parabola. Okay, so now let's look at the maximum part first. So when is the vertex maximum? When we have opened upward graph or opened downward graph?
Downward.
Downward, right? Yes. Okay. So here is the maximum point. So that's the vertex. That's the vertex. Okay. So maximum means A is negative. And minimum means A is positive, which is this point. Okay. Now, since vertex is a point, it has the ordered pair representation. And what's the ordered pair? H comma K. Okay, so that's the representation of the vertex, and which is why this secondary form was called the vertex form, because we can see H and K, right? Okay, right there. Okay, and now here is a remark about this vertex. Whenever the problem says find the actual maximum or minimum value of the function, that denotes the K value. And what does K represent? The Y value from the vertex. Y value from the vertex. Okay, so the actual maximum or minimum value means the K, not the entire vertex. Okay, so be careful with that. And now, the next definition, axis of symmetry. Or sometimes people say axis of parabola, it means the same thing. So this means the vertical line through the vertex. Now, remember, any vertical line has the form x equals a number. Remember that? There is no y, right? Now, since this vertical line goes through the vertex, which has h, k as their coordinates, x has to be equal to what? H, right? Okay, so that is the equation of axis of symmetry. And now, by the way, going back to this picture here, where is the axis of symmetry? This, right? And this. And you can see why it's called axis of symmetry. Why? Because in terms of these dotted lines, the graph is symmetric, right? Okay, so those are some terminologies. Any questions over these? Okay, so now we'll look at several characteristics for each representation of the quadratic function, which is on the next page. And it has, I think, 5 or 6 facts. Okay, some of which are kind of tricky. So let's fill in the blank. So facts about ax squared plus bx plus c. So the graph opens upward. In other words, it's concave up if a is positive, and opens downward if a is negative. Okay, we have just seen that before, so it's nothing new here. Now, here comes the first important point. The vertex. Okay, we saw that it's equal to h, k. But what's the problem here? We have ax squared plus bx plus c. So there's no h and k, right? So what does that mean? We have to find h and k. So what's the formula? H is equal to negative b over 2a. And k is equal to f of h. So what does it mean? You have to first find h, and then to find k, you have to plug h into x. Okay, and be careful with this extra negative sign in front. So it's negative b over 2a, not just b over 2a. Okay, and then axis of symmetry is equal to x equals h, which we just saw it. Okay, and now here's another tricky part: intervals of increasing and decreasing. Whenever you see intervals of increasing and decreasing, you always have to remember that this deals with h. Okay, the x value from the vertex. Now, there are two cases. A is positive and A is negative. Now, we know how the graph looks like when A is positive. It looks like this, right? Okay, and now on this graph, where is h? At the very bottom, right? Because that's part of the vertex, right? Okay, and now can you see where the graph is increasing and where the graph is decreasing from here? Yeah, where's the graph increasing? Right there, right? And where's the graph decreasing? Right there. So what does increasing represent? Increasing means what? X is greater than h, right? Because it's on the right-hand side of h. Okay, so what is the interval notation? Parentheses h, comma, infinity. Okay, and then what is the decreasing? Where's the decreasing case? Anything less than h, right? So x is less than h. And what does that mean? negative infinity comma h, parentheses. Okay, now the good thing is when a is less than 0, what do we have? The opposite graph, right? So can you guess what will happen to these two intervals? They will also be what? Flipped, right? Okay, so what does that mean? Here is h, and here is increasing, and here is decreasing, right? So what does that mean? That becomes increasing, and that becomes decreasing, right? Okay, so in other words, increasing is now negative infinity comma h, and then decreasing is h comma infinity, which is the opposite of the previous case. Okay, so now here it's kind of scary to memorize these four intervals. So my suggestion is do not memorize these four intervals. Rather, what you have to know is whenever you see increasing and decreasing intervals, remember two things. Oh, it has to deal with h. And use the graph. Okay? What do I mean by the graph? It's either this one or this one, right? There's nothing else. Okay? So as long as you can draw the rough graph, either this one or this one, it's fairly automatic. You can like see it from the graph, where the graph is increasing and where the graph is decreasing, okay? So don't even try to memorize these four intervals. It's scary, okay? So just use h and the graph, that's all. Now, the similar case appears on the range. Now, the range is the y value, and the range deals with k from the vertex. Okay, and the good thing is, still you have to use the graph as well. Why? Because when a is positive, you still have the same graph like that. And now, where is k this time? Still at the bottom, right? Okay, and now remember, range is the y value. So now, where are all the y values on this graph in terms of this k? They lie above or below k?
Above.
Above, right? Yes. So all the y values lie above k. Now, is there any math symbol for above? Greater than, right? Now, can y be equal to k? Yes. And what does the equal sign mean? Your y hits the vertex, right? Okay, so it's this one. Y is greater than or equal to k. And what's the interval notation? Bracket k comma infinity. Okay. And now, what do you expect about this second case? It's the opposite, right? Okay, so this time, where are all the y values compared to the k? All the y values lie below k, which means what? Y is less than k, right? And now, similar question, can y be equal to k? Yeah, because y hits the vertex. So what's the interval notation? Negative infinity comma k bracket. Okay, so again, my recommendation is do not memorize these two intervals, but just remember to use the graph and k for the range. Okay, so again, for the range, you use graph and k. For the increasing and decreasing intervals, you use h and the graph. Okay? So, now we have seen all the tricky parts, and now here comes the easy part, the domain. That. And what's the reason? There's no square root, there's no rational. Okay? So, it was indeed insane, right? And the most insane part was the parts that I put the stars. Okay? The vertex, increasing and decreasing, and the range. Those three are the most hardest part. Okay, so now, here is the good news and the bad news. So remember, we also had this secondary form, a times x minus h squared plus k. The bad news is there are also these 6 facts for this secondary form. Now, the good news is 5 of them are exactly the same. Okay, only one of them is different. So, number 1, opens upward and downward, same. Number 2, vertex, h comma k. Now, this time, do we see h and k? Here and here, right? Yes. So the vertex is h comma k, but be careful with correctly identifying h and k. So what does that mean? It's x minus h squared and then y and then plus k in the back. It's minus and then plus. Okay. And then everything else stays the same, increasing and decreasing, range and domain and so on. Okay, so only the vertex is different. Okay, so now, can I go to the next page? So, before we do any problems, now, remember that when you graph a line, you had to have what? 2 points at minimum, right? X and Y intercepts. For parabola, quadratic functions, how many points at minimum do we need? 3. Okay, we need 3 points at minimum. So, how do we choose these 3 points? Here is my suggestion. Choose the vertex. Okay, and then choose the y-intercept, which is what? Set x to 0, right? And then plug in an easy number to x. Most people end up choosing x equals 1 or 2 or negative 1. Okay. So now let's work on these problems. Find the vertex and the minimum value of the function using the figure below. Okay, so now this is kind of the easiest problem. Can you see the vertex right away? Negative 3, 3, right? Yeah. So the vertex is pretty easy. And now, what is the minimum value of this function?
Negative 3, 3.
Same thing? It's not the same thing. So remember, whenever you have maximum or minimum value of the function, what does it mean? The k value, right? So what is the answer? What is the k value from this vertex?
3.
3, yes. Okay, so the minimum or even maximum value, that's not the vertex, it's the k value from the vertex. Okay? Now, question number 2. Find the quadratic function, equation of the quadratic function whose graph is like below. Okay, so this can be a scary problem, but here is my suggestion. Start from the second form, f of x equals a times x minus h squared plus k. Okay. So now here from this form, what are the unknowns? The unknowns are not x, right? What are the unknowns? A, h, and k. Okay, so what do we do here? Find a, h, and k. Now, from this graph, can you find out what h is? What is h?
-1.
And what is k?
-12.
-12. Do you see why? Because they are the vertex, right? Or part of the vertex, okay? So that's the vertex. So that's why we get these two values. So what do we have? We have f of x equals a times x minus -1 squared, and then plus -12, right? Okay, which is equal to what? F of x equals a times x plus 1 squared minus 12. Okay, so we have used this vertex, but we haven't used another thing here. 1, 0. We haven't used that yet. So how can we use this 1, 0 to figure out what a should be? Any idea? This 1, 0 is on the graph. That's my hint.
Use the x value.
Okay, so how? Yeah, so like 1, 0 is the x-intercept, right? But it's on the function, which is this. So what can we do? So that's my hint. 1 is the x and y is equal to 0. Plug in what into where?
1 into a.
1 into a? 1 into... 1 into... Well, a is the unknown that we are trying to find.
X.
X. And set whole thing equal to what?
0.
0, yes. Okay, so what does that mean? A times 1 plus 1 squared minus 12 is equal to 0. Okay, so what does this mean? So that's 2 times, or 2 times itself, or 2 squared. So that's 4 times a minus 12 equals 0. So what is a equal to? 3, right? Okay, so what's the answer? The answer is f of x is equal to 3 times x plus 1 squared minus 12. And of course, if you want, you can FOIL this entire thing, but I'm not going to do it because that's not a hard thing to do. Okay, so here, be careful that a is not equal to 1. Okay, to find out a, we just use another point that's given. Okay? Okay, so now, can I go to the next page? Okay, so now, the main core of the section is this problem number 3 and the next problem number 4. And hopefully you can see why this problem is the main problem. For each quadratic function, find the vertex, axis of symmetry, increasing and decreasing intervals, domain and range, sketch the graph, i.e. what? Everything. Okay, so you have to find everything, so that's why this is the main problem. Now, let's try to find the vertex first. Can you see what the vertex is from this function?
Two and -4.
Okay, now 2 and -4, that's what many people say, but be careful. It's x minus h squared plus k. So h is not 2, but it's equal to what? -2, right? Yes, be careful. Okay, so this is negative x minus -2 squared and then plus -4. Okay, so h is equal to -2 and k is -4. Okay, be careful when this is positive. So it's at -2 comma -4. And now, axis of symmetry. Axis of symmetry. So if you remember from this fact here, axis of symmetry has the equation what? X equals h, right? Okay, so what's the equation of axis of symmetry? X equals -2, right? Okay, and now increasing and decreasing intervals. Okay, now remember this was part of that most tricky things. And what was my suggestion? Use only 2 things, right? The first one is the graph. And this one uses what? There's a specific letter or number that's been used, right? And what is that number or the letter? H. Remember that? Okay, so now we know h is equal to -2, so that's not a problem. Do we know how the graph looks like? Opened where?
Yeah.
Down, yes. And what's the reason? Because your A is negative, right? Which is -1. Okay, and now where is -2, which is h value? Here, right? So where is the graph increasing? That, right? So what does increasing represent? Anything less than -2, right? Okay, which is what? negative infinity comma negative 2 with parentheses, right? Okay, and where is the graph decreasing? Anything greater than negative 2. And what does that represent? Negative 2 comma infinity, right? Okay. Now, the domain. Is the domain pretty straightforward? Yeah, what's the domain? Everything, right? Okay, so that's pretty easy. Now, the range. So remember, this one was another tricky thing here. So the range deals with which letter? K, remember that? Okay, and K was negative 4. And remember, what was my suggestion? Still use the graph, which is this one, right? Okay, now here, where is the graph or the K? At the very top, right? Okay, and where are the Y values? All the Y values lie below negative 4, right? So what does it mean? Y has to be less than negative 4, right? Can Y be equal to negative 4? Yes, so it's this one, right? So what's the interval notation? Negative infinity comma negative 4, and we have to have a bracket around negative 4, right? Okay, and notice that I'm not even looking at the fact box from earlier, right? Because I'm just using the graph and then H and K, right? For the increasing and decreasing and the range. And that's all. Based on the graph, everything will follow, okay? And now, the last thing, the graph. Okay, now remember, we need 3 points. Okay, so we need 3 points, but we know already one of them, which is equal to what? The vertex. The vertex is at negative 2 comma negative 4. Okay, so we know one of the points. Okay, and now, second point, let's find the y-intercept. So what do? Set x to 0, right? Okay, now when you set x to 0 from here, what do you get? It's negative 2 squared minus 4. And what's the number equal to? Negative 4 minus 4, so that's negative 8, right? Okay, so the vertex or the y-intercept is at 0 comma negative 8. And now plug in an easy number to x. So what can we do? Maybe x is equal to 1. That's the easiest number. Okay, so what is y in this case? So when x is equal to 1, you have what? Negative 3 squared minus 4, right? And what does that represent? Negative 9 minus 4, so that's what? Negative 13, right? So what is the point? 1 comma negative 13, right? Okay, so plot these 3 points. Negative 2, negative 4. So negative 2 and then negative 4 is somewhere here. And then 0, negative 8 will be down here. Okay, and then 1, negative 13. Okay, so that will be, oh, like way down here, right? Okay, so now we know that the graph has to be what? Open downward, right? And remember, this was the vertex, right? So can you see the shape of the graph? It has to look something like this, right? Okay, so that's the graph. Okay, so now part B. Part B. 2x squared minus 12x plus 1. Okay, so now here, what's the problem? This is different from what we had in the previous part, A, right? So what's the issue? We cannot see what h and k should be, right? Right away. Okay, so what do we have to do to find the vertex? So to find the vertex, what we first have to do is what? Identify A, B, and C. Okay, so now here, what is A? A is positive 2, oops, positive 2, and B is negative 12, and C is 1, right? Okay, and now, do you still remember the formula for finding the vertex? So it was here. Okay, so I guess I should do this. Okay, so what was the formula? So the formula was, when you have ax squared plus bx plus c, h is equal to negative b over 2a. And then how do you find k? You have to plug h into x, right? Remember that? Okay, so negative b over 2a. So what does that mean? Negative b over 2a. So h is negative 12 over 2 times 2, right? Negative b over 2a. And now, what is this entire number equal to?
Three.
Positive 3, right? Yes. Okay, positive 3. Okay, so now, how do you find k? You have to plug in 3 into x. So what is this? 2 times 3 squared minus 12 times 3 plus 1, right? Okay, and what is this? So the first one is, or the second one is 36, and then plus 1 stays the same. What is the first number equal to? $18 or $36?
$18.
18, right? Yeah, it's 2 times 9, right? Not 6 squared, right? Yeah. Okay, so 18 minus 36 plus 1, so what is this? Negative 18 plus 1, so that's negative 17, right? Okay, so the vertex is at 3 comma negative 17. Okay, and now part number 2 was the axis of symmetry. So remember, it has the equation x equals h, right? And what was h? 3, so x is equal to 3 is the equation of the axis of symmetry. And now, increasing and decreasing intervals. Uh-oh, here comes the first tricky part. Okay, so increasing and decreasing intervals, what do we use here? H, right? And what? Graph, right? Okay, so now, how does the graph look like? Opened upward or downward?
Up.
And what's the reason? your
Because
A is positive, right? Okay, yeah. So here is the H value, which is equal to 3. And now from here, can you see the increasing and decreasing parts? Yeah, it's fairly automatic, right? Yeah, so where is the graph increasing? Here, anything greater than 3, right? Which means what? Parenthesis 3 comma infinity. And then where's the graph decreasing? Anything less than 3 right there. And what does that mean? Negative infinity comma 3 parentheses, right? Okay, so remember that for increasing and decreasing, we don't ever use brackets. And now the domain. Is the domain fairly easy? Yeah, right? So what's the domain? Still everything, right? And what's the range? Or how do we find the range? So this one uses what? K, right? And the graph as well. Okay. So now we know that's the graph. And where is K? Right at the bottom, right? Which is negative 17. And this time, where are all the Y values? They lie above the vertex, right? So that means Y has to be greater than negative 17. Can it be equal? Yes. Okay. So what's the interval notation? What's the interval notation of, oops, sorry about that. What is this? Hang on 1 second. There we go. Okay, so what is the interval notation? Bracket negative 17 comma infinity, right? Okay. So remember, for the range, there will be a bracket. Okay, and now graph. So for the graph, remember, we will be finding 3 points, one of which we already know. The vertex is at 3 comma negative 17. And now the y-intercept. So the y-intercept, you set x to 0, right? So what do you get? The first one is gone, okay, from here. And then the second term is also gone. And you are left with what? Just 1, right? So the y-intercept is at 0, 1. Okay. And now plug in an easy number. So maybe x is equal to 1. So what's the y value? It's 2 times 1 squared. So that's just 2, right? And then minus 12 plus 1. So what is this? Negative 10 plus 1, so that's negative 9, right? Okay, so it passes 1 comma negative 9. Okay, it passes 1 comma negative 9. So let's plot these points. So 3 comma negative 17. Okay, so that's maybe way down here. This is not in scale. And then 0 comma 1 is here. And then 1 comma negative 9 will be somewhere here. Okay, so now remember, the vertex was at 3 comma negative 17 and the graph is opened upward. So that means we have to have this U-shaped curve, right? That looks something like this. Okay. Any questions on these two problems? Okay, yeah, it's a lot, I know, but we are just repeating all the schemes, so that's kind of a good practice. Now, this is pretty easy. X squared plus 2. Okay, so now here, we have x squared plus 2. So let's find the vertex. And now we will find the vertex in a simpler but different way. So for the y equals x squared graph, which looks like this, where is the vertex?
At the origin.
At the origin, right? Okay, now we have x squared plus 2, x squared plus 2. For x squared plus 2, what do we have to do? So for this graph from here, from x squared, this graph has to be moved into where? Something like this, right? You see that? Okay, so where's the vertex? That's the vertex, right? So can you deduce what the coordinates of the vertex is?
0, 2.
0, 2, yes. The vertex is at 0, 2. Okay. So now that's the vertex. And what is the axis of symmetry? So axis of symmetry is x equals h, right? And here, what's the h value? 0, right? So what does that mean? X equals 0 is the axis of symmetry. And then part number 3 was increasing and decreasing intervals. Okay, so remember, increasing and decreasing intervals use h. Okay, and then from the graph, which is this one, we already know how the graph looks like. Where's the graph increasing? On the right side of 0, right? And where is the graph decreasing? On the left side of 0, right? So what does that mean? Increasing would be x greater than 0, i.e. parentheses 0, infinity, right? And then decreasing would be anything less than 0 or negative infinity, 0. Okay? And now the domain is fairly easy, negative infinity, infinity, right? It's everything. And now the range. So remember, the range uses the k value, which is 2. And the graph is opened upward, like this. So all the y values lie above 2, right? Can it be equal to 2? Yes. Okay, so what is the range? Bracket 2, infinity. Okay, so now we know already how the graph looks like, which is this, right? But let's try to get a few points. Okay, so we'll get a few points. So first, the vertex. The vertex was at 0, 2. Now, can you guess where the y-intercept is?
2.
Right, it's the same thing, right? 0, 2. Okay. So what is the problem here? We only got 1 point, right? Yeah, so we have to plug in what? Two numbers, say 1. And here, what is y? 1 squared plus 2, which is equal to what? 3, right? Okay, so another point is at 1, 3. And then you can try x equals 2, for example. Okay, so it's 2 squared plus 2, which is equal to what? 6, right? So it's at 2, 6. So we have 2, 6, 1, 3, and 0, 2. Or you can plug in like -1, okay, for example. Okay. Okay, so that was number 3. And now let's do the only word problem of the section, which is still important. So number 4. Henry owns a hot dog stand at Weatherford College. That's obviously false. I don't own any hot dog stand. His profit P of X in dollars from selling X hot dogs is given by -x squared plus 10x plus 34. Answer the followings. Find the number of hot dogs he has to sell so that he earns the maximum profit. Okay, so now in this part A, there is a keyword. There's a keyword. And what is the keyword?
Maximum.
Maximum, yes. Okay, and now, why is this a keyword? Because in this section, where have we seen the word maximum or even minimum? The vertex. Okay, so whenever you see the maximum or even minimum, it means the vertex problem. Okay, so what does that mean? Find the vertex. So now the given quadratic function is -x squared plus 10x plus 34. So what do we have to do? Identify A and B and C if you want. Okay, so A is -1, B is 10, and C is 34. And remember, what is the formula? H is equal to -b over 2a. Okay, and then k is obtained by plugging h into the function, right? Okay, so what is h? It's -10 over 2 times -1. And now, what is this number equal to? -10 over 2 times -1.
Five.
+5, right? Yes. Okay. And now, what is k? It's p of 5, which is equal to -5 squared times 10 plus 5 plus 34. Okay, so this is equal to, so something plus 50 and then plus 34, right? And now, what is the first number equal to? Is it +25 or -25? The -25, right? Okay, be careful, it's not positive because this is 5 squared and then times negative sign, right? Okay, not negative 5 times itself. Okay, so what is this? 25 plus 34, so that's 59, right? Okay, so the vertex is at 5, 59. So now, going back to this problem here, what is the answer? Find the number of hot dogs he has to sell to maximize the profit. So here you have 3 choices, 5, 59, 5, and 59. The answer is among these 3. Which one is the answer?
59. 5.
5, yes. And what's the reason? Because it says the number of hot dogs. And which letter pertains to the number of hot dogs? X,
Yeah.
right? Yeah, okay. So 5 hot dogs. So what does 59 represent then?
The dollars.
The dollars, yes. Part B, what's the maximum profit? So that's the K value, which is equal to $59. And you can see why Henry doesn't own this hot dog stand at Weatherford College. Why? Because he has to sell 5 hot dogs and he'll earn 59, nearly $60 as the profit. So what does that mean? That's like nearly $12 per hot dog. And yeah, that's pretty expensive. Okay, so that's why there's no such hot dog stand, but whatever. Okay, so this is an important word problem, okay? And here is the end of exam 2 materials. Okay, so any questions over 3.1? Okay, so we did this kind of in a fast way. So now let me briefly start the next section 2.7. So we are going back to chapter 2 and then we will cover this last remaining section and then we'll go to chapter 3. Okay, so now here we will talk about translations and transformations. Somehow I put a dollar sign, but it's actually false. Maybe because I like money too much. So translations and transformations. So we will apply some changes to the graphs. Now, what kind of changes am I talking about? Like moving left and right, okay, and up and down, and then stretching, and then compressing, and then reflecting. Okay, like those kind of changes. So what is the easiest thing here? The translation. Okay, now the word translation means we change the position of the graph. But what about the shape? We don't change it. Okay, so now there are 2 ways to change the position. You can move the graph up or down, or send it to the left or send it to the right. Okay, the first one is the vertical shift. Okay, again, this means move up and down. And this one is fairly straightforward. And here is the setup. F of x plus b. Okay, so we add something at the end of the function. Okay, so now think about it. Whenever you are adding something, does that mean we have to go up or down?
Up.
Yes, right? So move f of x up. And for this translation, we specify the distance of motion. And what's the distance of motion? How much we add. Okay, so add something, we move up. Now, subtract something in the back of the function means we move f of x down. And again, by the same units, b, which is how much we subtract. Okay, so it's really straightforward. Now, the horizontal shift is a bit tricky. Okay, so this one is tricky. This one means move left and right. And now the setup is the same. We have a function and the b. Okay, now move f of x left b units. So now think about it. If you want to move function to the left, do you have to add something or subtract something?
Subtract. Subtract.
Okay, yeah, right. Subtract is the intuitive way, but here, unfortunately, that's not true. That's not true, okay? So here we have to add. And what matters is where we add b. Okay, so where do we add b this time? To x. Okay, so we add something to x and everything stays within the parentheses. And that means it seems like we have to go right, but no, think backwards. We have to go left. So conversely, if we want to go right by the same units, what do we have to do? Subtract. And again, where do we subtract b? Within the parentheses, okay, behind x. So again, we think backward. Okay. So as a hint, whenever you come across the word horizontal, remember that you have to think backwards. Okay, so in other words, you have to flip it, like you have to think backwards. So that's why this is the hard part. Okay. Okay, so I guess we already went over time. So we will cover this section starting tomorrow. But so now tomorrow, remember, is the exam day, right? Okay, so since I kind of barely finish it everything toward the end of today's class, my suggestion, if you want, is you can maybe choose to take the exam at 3:30 slot or maybe in the night so that you can have a little bit of more time to study. But of course, if you have work or any other things to do in the afternoon or in the night, then maybe morning is the only option, okay? So if any of you choose to take the exam in the morning, remember we will do the exam for the first hour and 20 minutes. And then for the rest of the class, we'll just have a lecture, okay, or like over these. Okay, and if any of you wants to take it in the afternoon or in the night, then remember to join the Zoom by like maybe 11:15 or so. And maybe people have already finished it, like I don't know, but you can just join in like at 11:10 or 11:15 and see how everyone else is doing. Okay, and remember another thing. So remember to lower your speaker volume, like on your phone, okay, so that you don't have to hear the sounds from other people, okay? Like it's not the sound that other people are intentionally making, okay? It's just the natural sound, but it might be distracting to some or many of you. So just lower your speaker volume so that you don't have to hear other people's sounds, okay? And also, let's see, the second extra credit homework is due tomorrow. So you don't have to turn that in like before you take your exam. Okay, so you can even turn that in after you're done with the exam. Like it doesn't really matter. So that's due tomorrow at any time, but preferably before the night. But any other questions? Okay, so I'll see you tomorrow in class with the exam or without the exam. If without the exam, I'll see you in the afternoon as well. But anyways, so that's it for the day. I'll see you
Have a
tomorrow.
great day.